Okay, so for today's lesson, we're doing scale, continuing with scale, and we're doing similar objects, okay? So similar objects, scale models, and scale diagrams. So we use scales when we want to either make a image bigger or if we want to make it smaller. So making it bigger, so we do in like biology, right? If you have like an image of a cell, we can't see it with the naked eye, so we magnify that. We use microscopes and other instrumentation to allow us to see that. And we also have really big things that we want to put on a piece of paper, like the blueprint of a school, for example, right? We would shrink that down using a scale factor, okay? So, I have a question for you guys. So we have two rectangles we're going to start with. Are these following shapes proportional? Okay, so what does proportional mean?
I've never been so disappointed.
What does proportional mean?
I've heard of it.
I don't know what exactly mean.
What?
I don't know what exactly mean.
What's
Like a portion of the actual thing.
okay? A portion of the actual thing, yeah. Were you gonna say that? Yeah, so it's a portion of the actual thing, but just at like a different size,
Yeah.
right? Yeah. Yeah, exactly. Like we talked about, like the scale factors for like a cell or a blueprint of a school, right? So if they're proportional, they're going to be the same ratio to one another. Okay, they're going to be the same ratio, just different sizes. Okay, so we have a ratio of 9 to 2 and 22.5 to 5. Okay. So are they proportional? Are they multiplied by the same scale factor to get to one to the other? Okay, so let's ask ourselves, how do we get from 2 to 5?
Add 3.
And think of multiplying, okay? Times by 2.5, good. Now, if we want to see the 9 and the 22.5 is also proportional, we need to multiply it by 2.5 to see if it is multiplied by the same factor. Okay? So if you do 9 times 2.5, it is indeed 22.5. So, Logan,
Yeah.
are these two rectangles proportional?
Yeah.
Why?
Because they're both multiplied by the same units.
The same units and what we call the scale factor, right?
Yeah.
And what is the scale factor for our two rectangles?
2.5.
Yeah, good. 2.5. Good. And we're getting bigger, right?
Yep.
So is it 2.5 to 1 or 1 to 2.5?
2.5 to 1.
Good. Okay? So let's look at these two circles now. Okay? One has a radius of 16. One has a radius of 4. How do we get to from 16 to 4?
Divide by 4.
Divide by 4, yeah. Or we can multiply by 0.25. 0.2. Same thing. Same thing as dividing by 4, right? 1 divided by 4 is 0.25. Okay? So you can either divide by 4 or multiply by 0.25, and then you get the radius of 4. So, are those two circles proportional
Yes.
to one another? Yeah, they are. Okay, good. And by what scale factor, Cody?
0.25.
Okay, and if we want to rate it as a ratio?
1.0.25. 1 to 0.25.
Good. Good. Okay, fantastic. So, we have, we're entering 3D objects now, okay? So we're getting into another dimension. Do you guys know what the 3 dimensions are?
No.
No, probably, but
Like left and right, essentially, right? Up and down is the second one,
Yep.
right? Your third one is going to be depth, like you see in this cube here. And the fourth dimension, what do you think it is?
Movement.
Close. Movement of what? What can we not see, but is always moving?
Air.
At a time.
Time.
Oh.
Time is our fourth dimension. That's Einstein's like theory of relativity, how time and space are related to one another. Pretty interesting. Anyways, so three-dimensional square is a cube, right? And if we have an original cube with a side length of 5, okay, all of these other side lengths are the same. And if the scale factor is 2/5, what is going to be the side length of the smaller cube? Scale factor is 2/5, right? So anything that is 5 is going to become 2. Yeah, 2. 2, good. Okay, and this is a cube, so all of these sides are also going to be 2, okay? Now, what about these cylinders? If our scale factor is 200%,
Well, they double.
they double, yep, for
So
sure.
it'd be 24 and 8.
Yeah, perfect. So my height is going to be 24, and my diameter is going to be 8. You bet. Good. Questions so far? No? Alright. So, in summary, for two 3D objects to be similar, and you guys gotta write this down, they must have proportional dimensions, i.e., they all must be increased or decreased by the same scale factor. Okay, write that down, please. Alright, then. So, if two objects are similar, then they will have the same ratio for all the measurements that we can compare. So one cylinder, so the cylinder on the left here has a radius of 15 centimeters and a height of 24 centimeters. Another similar to the first, has a radius of 22.5. What is the height of the second cylinder? What are we going to do?
36.
36. You're right. How did you get that?
Wow. I just went 22.4 divided by 15, which got how many times bigger the other one was.
Okay, good. So, because we know the radius on both of the cylinders, Cody went to find what factor we multiplied that by to get there, right? So he went 22.5 centimeters divided by 15 centimeters, and that is equal to 1.5. This is our scale factor. Does our scale factor have units? No, it does not, right? Good. Okay, so we know to get from 15 to 22.5, we multiplied it by 1.5.
Yeah.
So what did you do to the 24?
Times by
Cody?
1.5.
You multiplied it by 1.5, and we found out that our height was equal to 36 centimeters. Excellent. That's all good? Great. Okay, so Nadine has found plans for a book end in a woodworking magazine. The plans include a scale diagram with a ratio of 1 to 5. So we're getting bigger or smaller?
Bigger.
Getting bigger, good. So let's determine the dimensions of the actual book end, okay? So this is the magazine drawing, okay? So length, height, width, and base thickness. So let's just identify what is what, okay? So this 2 inches is going to be my height, right? this 1 inch down here is going to be my width. What is the length going to be? That will be right here. That's going to be my 1 1/2 inch, right? How long is the actual bookend? And then the base thickness is right here. Okay, so this is base thickness.
Okay, so for height, 3 inches,
So what?
just times all those numbers by 1.5.
Wait, what's our ratio? What's our scale ratio here, Cody?
1.5.
Huh?
1.5.
Do you need
Oh, 1 to 5.
1, 2, 5? Yeah, you bet. So everything is getting bigger by how much?
5 times.
5x, right? So if our base, where do you guys want to start? Base thickness?
Well, the height is 10 inches.
Sure, let's start with the height. Okay, so we start at 2 inches and our scale factor is 5. Okay, so we'll do that by 5.
Our thickness is 8.7.
So our height is 10 inches. Good. You want to do thickness next?
8.75 inches.
So base thickness, we have 1/4 inch multiplied by 5.
Oh, 1/4. I did 1/3.
Yeah, 1/4 inch. So if you have 5 quarters in your pocket, how much money do you have? $1.
$6.25.
$1 and 1/4, right? 1 1/4 inches. Okay, for our width, it is 1 inch times our scale factor of 5. So it'll be 5 inches wide, and our length is 1 1/2 of an inch multiplied by our scale factor of 5. And we get 7.5, 7 1/2 inches for that. Agreed? All good? Okay, so just finding our scale factor, understanding how to interpret what the ratios are, right? That's probably the most important part about this. Okay, 2 to go. So this one we'll do together. Next one you guys are gonna attempt on your own.
This one that they gave me is like.
I don't have one. Sorry. Okay, so Josie went to the zoo. Her mom bought a stuffed toy gorilla, which is right here. That measures 4 inches high. Okay, this is the image. Or the drawing, okay? If a male adult gorilla grows to be 5 foot 6 inches high, so this dude is 5 foot 6.
5'11". That's like Brandon's height. What? You're 5'6" or 7", right? I'm 8.5. Emphasize that. That's why I said it.
Okay, so male gorilla grows to be 5.6 feet high. So what scale factor was used to make the stuffed gorilla? And I changed this. So let's say instead of 5.6 feet, we can say 5 foot 6 inches. Okay?
Okay.
So if you want to find the scale factor, how do I calculate that?
For every 1 inch, it's 1.4 feet. So the scale would be 1.4 to 1.
Nope. Okay, because you need to make sure that you have them in the same units, right? This is feet and inches. This is just in inches.
So 12 times 5.
So scale
6,
is equal to
7.2.
expectations versus reality, right? So
66
image
inches.
over actual, right? Image over actual.
For every 1 inch of the stuffed bear, there's 16.8 inches of the real gorilla.
So 4 inches divided by, what is the actual size? So 66 inches,
What?
good.
There's 67.
No,
66. It is 5'6".
12 inches per foot. So 12 times 5 is 60, plus 6 inches is 66 inches. So 4 divided by 66 is what?
0.6.
Okay, so-
0.06 repeating.
0.06 repeating? Like that?
No, it's 0.06. It's
So it's
repeating.
1/16.5
Oh, okay.
ratio.
Oh, 6, gotcha. Gotcha, okay? So what scale factor was used to make the stuffed gorilla? So it is getting much, much smaller, right? So how do we turn this into a ratio or a fraction?
About that.
The math button, and what does it tell us?
2
2/33. 2/33, and as a ratio, what would it be if it's getting smaller or it's getting bigger? Sorry, the stuffed gorilla is getting smaller, right? So what is it going to be as a ratio? 33 to 2, right? Good. 33 to 2, you bet. Questions there? Does that make sense? Okay, so I want you guys to try this one on your own, okay?
For every 1 inch, there's 8 feet.
On this one?
Yeah.
Okay. Okay, so this is a postcard of the totem pole. Most postcards measure 3 by 5 inches, so we'll assume that this is a regular postcard. 5 inches by 3 inches, okay? If the actual totem pole was 40 feet high, what scale factor was used for this image? So what is one thing we need to...
To get 40 feet into inches.
Good, so convert feet to inches, you bet. Okay, so we have a postcard, a totem pole. We know how tall the totem pole is. Okay? And we're trying to find the scale factor. So remember, scale is equal to expectations over reality. So image over, what did we say? Image over actual. Drawing over actual, okay? So in the image, we know it is 5 inches tall. Cody?
Yeah.
Don't.
I got thrown in first.
Okay. So the whole thing is 5 inches tall. But what is the height of this totem pole? What is the height of the totem pole, Cody? Is it 5 inches? Is it the whole postcard?
No,
No.
about 3/4 of the postcard.
You said 3/4? I said it was about 2/3. That's okay. That's okay, right? So yeah, so I'm gonna say this is about approximately 2/3 of postcard. Therefore, 2/3 of 5 inches is 3.35 inches for the totem pole. Okay, so I'm saying that this right here is 3.35 inches. Okay? So image 3.35 inches over the actual, so it's 40 feet. So 40 feet times 12 inches per foot
This is missing.
equals 480 inches. Okay, so if you divide that, you get 0.00698. I rounded my last digit there. Okay, if we turn that into a fraction, it is 67 over 9600. So if we're making the image on the postcard, what is going to be my ratio for the scale factor?
Oh, and then, oh yeah, then we put it in like,
I think I like the ratio the best. So how would I write it as a ratio if it's getting smaller?
67.
Other way around, right?
I
If it's getting smaller, it'll be 9600 to 67, right? As a ratio.
Do you but then would you not want to put it in lowest terms?
This is as simplified as it gets.
You couldn't go 9,600 divided by 67, and then have 67 as 1.
Oh, you could, but it's just gonna give you, this is like an exact answer, right? If you were to reduce it any further, it would be an approximation, right? Because 67 is a prime number,
Yeah.
right? So it can't be reduced any further.
Right.
But yeah, no, you're absolutely right. If we can, we can put it into lowest terms, right?
That's where I messed up.
So let's see. What's 6,700? Well, 67 divided by 9,600 is 0.00698, which is like 10 thousandths. So it would be like 10,000 to 6.98, or just 69.8 is what it would be. But even then, that doesn't really make it look better, right? So yeah. Okay, good. So here is your practice problems associated with this topic.